YouTube पे वाला कर रहे हो क्या अभी?
Yes, yes. X character.
पहले सुनो पहले CD बता दो।
अरे स्टार्टिंग ये भी
प्लीज पहले CD बता दो।
अरे बता दूंगा भाई, टेंशन ना ले भाई, बता दूंगा भाई।
एक्सटेंड अरे पंडा चल
लास्ट तक के एलिमेंट्स नहीं दे सकता, फिर अगले प्रीक्वेसर में से एक ले।
पंडा चिल टॉक्स में
सीडी कर रहे हो क्या? अरे भाई ठीक है। So starting off with problem A, it was pretty straightforward. So we are given a string of some length, right? And it is beautiful or good or what have they said, it's universal. ठीक है. So it's universal if, let's say, this one character third and this is the fourth character, and if I do the reverse of these, string A should be lexicographically smaller than string B. String B is the reverse of string A. So if I note this as A, note this as B, and the other relation is A reversed is equal to B. Okay. Now what is given in the question? Are required to make S universal. Okay, I can perform at most K operations to make it universal, but am I correct about the definition? R is lexicographically smaller than the reversal. Yes, okay. So reverse of this, and what I want is A should be smaller than B. Okay. So this is my condition. Now, what I want is, I have a few things over here. First, I can check if obviously the reverse of A is smaller than B, then I don't need to perform any kinds of operation and I can just output a yes. But if it is not, then I will have to make a change, right? Let's assume this is the last letter of B and I have a few letters over here. Let's assume this is the last letter of A, right? And it is not, so that means this letter is smaller than or equal to this letter, correct? So I just need to replace this with something that is different, right? Okay. This is not smaller than or equal to, I believe. It should be, I have an A, wait, okay, so reverse may it is smaller. So I have a B here, and if this is a D, yeah, okay. So this is obviously smaller than or equal to this, right? So when this is the case, if these two are not equal, I can just swap both and my string becomes different. But if these two are, let's say, equal, I want to swap this with something greater than this character, than this. So if I have a B here, I want to swap this with something greater. But if I just can't swap, if the whole string is B, then the answer is no. Else the answer will be yes, I can swap with anything that is greater. So let's say a C or anything like that. But this should be made greater, or this can be swapped with something smaller. That is also doable. So this is how we can solve this problem. Again, going to the code. First, we are checking if the string is lexicographically smaller than its reversal, then it's a yes. And if at a point we know it is greater, then we just break it up. Now, if my k is 0, I can't perform a single operation. We just output a no. Now I'm just checking if there is just one character, then obviously I can't change things. But if there is more than one character, I can just swap here or I can swap here, depending on the situation. That is A. Any doubts? Hello?
No doubt.
Okay. So jumping to B. B, what I have been said is, So this is B. Okay. Okay. So B, I have a sequence. Okay. And what I will do is I will select some sort of an LR and I will replace that LR with its max value. Okay. I'll replace this LR with its max value. So if this is replaced with its max, my array length decreases by R minus L because I am adding also one term and removing this whole thing. Okay. Now I want there to be exactly one element in my array and that element has to be a 0. Okay. So if I want exactly one element and that element has to be a 0, so my penultimate array where I will query the whole array should not have a single 0. Correct? So basically, I want to eliminate each and every 0 in my array. That is the point of this thing. Right? So if I have some sort of a 0, if I don't have a 0, I can just query the whole array and I'll get a max 0. But if let's say I just have a single 0, then I can query that 0 and the element besides it. The max will obviously be greater than 0. Let's say this is not a 0. Let's say this is a 5. Anyhow, since I have a 0, the max is obviously going to be greater than a 0. And if my 0 is at the end, we query 1 here. So my max is obviously going to be greater than a 0. And since it is greater than a 0, I am all happy. Like now I have eliminated my 0. But now let's assume if there is more than one 0, so there's two zeros or more than two zeros and stuff like that. Okay. So let's assume I have a 0 here and I have a 0 here. Not here, but let's assume this and this. Currently, I can't query all the zeros here. Correct? So what I do is I query the final 0 and the penultimate one. I query this 0 and this 0 and everything until here. So now I will have eliminated any zeros that were here. I will have eliminated any zeros that were here. And I have my answer. Correct. So I think your answer can arrive with just a single query. I have written a very complex and useless code, but your answer can just be this, that you just keep 2 points and remove any and every 0. So your thing is that you have to just remove any and every 0 over here. So you just remove a 0 here and you remove this 0 here. So this can be done. And if you have a 0, let's say something like this, so you just remove from the first 0 to the last 0. The rest array is obviously non-zero. So you just removed each and every 0 in one go. Now here you can't do it. That is why you are putting it as an edge case. You are considering the whole array. So it's the same here. First we check if there's no 0, we get a 1. If there's a single 0, the one ahead of it or the one behind it. Basically, if it is the end, the one behind it, else the one ahead of it, and then our array. Now these two are the same, but no big deal. These two are literally the same thing. You can just see this, instead of second 0, I just have to put a last 0 over here. It's the same. So if my zeros are at the end, then from the first 0 till the n minus second 0, I am querying. Then 2 and 3 I am querying, and 1 and 2. 2 and 3 is basically, since I've queried this, I have 1, 2 and 3. Now these two I'll be querying. So I'll have 2 parts, and these two I'll be querying. I'll have 1 part. So this is basically the structure. If I remove this, if I just put this in an else condition and I put last 0 over here, and this code can also work, I believe. Yes. Yes. This code can also work. This is also fine. But in the contest, I had written second 0 case first. So in a hurry, I just copy pasted the whole thing again. over here instead of making the changes there. This is the second question. Any doubts?
There will be two more edge cases, right? Starting with 0, 0 and ending with 0, 0.
Starting, so it's covered here, right?
No, only two zeros, and both of them are starting.
Both
At
of them are starting.
First and second.
This and this.
Yeah.
So I'll just put this and this.
Oh, okay.
Like I'll have at most 4 numbers. Sorry, at least 4 numbers. That is given in the problem. If you see, I have at least 4 numbers. So since I have at least 4 numbers, I can solve this. Correct? Like I can, like
Yes.
this thing can work for me. N minus 2 and the last 2. This thing can work since I have at least 4 numbers is the thing. Yes.
I thought your approach was to take from the first 0 till the last element from the second 0.
No, my approach is basically take the first element and go up until the n minus 2th element. This is the n minus 2th element. And then take the last 2 element. Take the n minus 1th and the nth element. So this was my approach.
Okay, I had done some complicated thing.
And if this condition isn't satisfying, I can literally take all the zeros together, right? Because I'll have at least one number that is a non-zero left and I can query it in the array for a 2. Understood?
Yeah, right.
Yes. So that is B. Now coming to C. So C, I am given an X and a Y. I need to find a number K such that I do X plus K, Y plus K, and the addition of these two as well as the XOR of these two is equal. So basically this condition, if you all see, I hope I can copy it. Yes, nice. Yes, so basically this condition holds is my criteria that this condition should hold. Now, for this condition to hold, let's just forget K. If I want X plus Y to be equal to some X XOR Y, what is one thing that I can have? One thing is, if my X is 1 0 1 1 0 0 something like this, the one thing that I want is, if there is a 1 at X, 100% there should be a 0 at Y. Correct? And if there is a 0 at X, I can have a 0 at Y. But if there is a 1 at Y, there should be a 0 at X. Understood? So if 1 at X, 0 at Y, wait, I'll just write it on Sublime, it's better. So if I have, if 1 at, I'll just comment this out. If 1 at X at any position in X, then at same position in Y. This is a binary representation, and same thing can be said for Y, right? So these two are the conditions that I require, like I compulsorily want, right? Because what is XOR? I can, if I add also, I am going to get 1 and stuff. And if I XOR also, I am going to get the same kind of stuff, right? I'll have a 1, I'll have a 1, 1, 1, 1. The addition as well as the XOR is going to remain the same. But now so this is the case, right? Now here, what can be done so that I add something here and I add something here also, and the same condition holds. Okay. So the first thing is I might have some x which is like this. Boom, 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 boom. 1, 1, 1, 0, something like this. I might have a y that is something like this. If I can just put my x ka MSB over here. And so basically I want to convert x to 1 and everything else is a 0. So if I can convert my x to that, I am happy. Correct? Because anything be in y, everything will be connected to a 0. And I am also considering my x to be the greater element here. So ऊपर तो 0 ही है. There is a 0 in x. So I can have a 1 in y or a 0 in y. I don't care. And I have a 0 here 100%. So that's just what you had to do. You just had to convert the bigger element to you just had to shift the MSB of the bigger element. Now this won't work in the case where x is equal to y. The main reason being they are always going to be the same. And if x and y are always the same, their MSBs are also going to be the same, which is not possible. So that's basically it. You have to iterate and make this to the new MSB. So here is the solution for C. Basic. This is the get MSB. I get the MSB 0 based indexing I am using. So if both are the same, we see out -1, and I make x always the greater one, and my answer will be my new value is MSB. So new value minus x, because that is what I have to add to x to make it greater. And this is my answer, and I'll just print my answer. That's it. Understood? See?
Yes.
Okay. Now moving on to D. What does D tell us? Like I have used a sec tree. There is no requirement. But okay. What D tells us is I have an array. Okay. Now at point I have three options. Either take in k sushis, either eat one sushi, or do nothing. Right? So either you take k sushis in your plate, you either eat one sushi, or you do nothing. Okay. And at every point. Now, at every point, I am, and every sushi has a deliciousness D. Right? Every plate of sushi, rather, every k sushis together have a deliciousness of D. Okay. So now I have to go, and until here, my plate should be empty. Basically, I shouldn't have a sushi remaining in my plate. So whatever I have taken in my plate, I have to finish it. That is the question. Okay. So the first thing that comes to mind is, what is the maximum number of sushis that I can take? Right? So if I have, right? So that, okay, let's assume you are to take only one sushi, right? So I have some sort of an n. Assume you are to take exactly one sushi. So at point n minus k, let's consider your n to be 100 and k, let's say 20. Okay. Now, if you want to take exactly one sushi, then from 1 through 80, 1 through the 80th plate, you could take the sushi anywhere and you could finish it here. If you took the sushi at the 81st plate, which is n minus k plus 1th plate, then at n minus, then you won't be able to finish all of them by the 100th plate. That is our issue. So we know that if I want to take just one sushi, I have to take it up until here. Okay, that's great. But now if I want to take two sushis, by what time do I want to take it? So let's assume I am taking my first sushi over here only at place 80, right? So my second sushi, like the second plate or whatever you want to call it, K, should be over by 79. Correct? And over here at 59, we will be taking another sushi. So latest by 59, I have to take the first sushi if I want to take two sushis. Correct? The main reason being, I need to finish this at, like over here, I need to have exactly 20 left. So meaning I could take the 80 wala sushi somewhere here also. I could take 59 wala sushi also somewhere here. Completely fine. And continuously just finish eating. But before 59, I need to take my first sushi. Anyhow, if I were to, in the worst case scenario, if I were to take my sushi at 80th time, and currently I'm taking just two sushis. Correct? So again, moving forward by this logic, I have a 58 here, and this will be 38, and another point where I will have to take a sushi will be 38 minus 20, which is 18 minus 1, 17. So I can at most take 4 sushis, and the first sushi has to be taken until 17, second has to be taken till 38, third has to be taken till 59, and fourth has to be taken till 80. So this is the time where I have to take the sushis if I want to complete them all by 100. Now again, just think, if you took, like, let's again go to the two sushis. If you took a second sushi here and here, right? So we are at n minus k. The second sushi, we are claiming that we have to take at n minus k minus 1. Okay. So this is where we have to take our second sushi. So basically n minus 2k minus 1. This is where we have to take the second sushi. But let's assume we didn't take the second sushi here. We took it at some place plus x. Okay. So we took it at some place x, which is greater than this, but less than equal to n minus k. This is where we took our first sushi. So since I have taken my first sushi here, I have added a 40, sorry, I have added x plus 20, and I'll be taking another sushi at some point, which will add another 20, right? Which I have to complete. And since, or rather let's say a k and k, which will add a k for me. And if I take the second sushi also here only, I'll have another k to complete, right? I'll have 2 k's to complete, but the amount of time left is greater than, sorry, is less than 2k. Why? Because like till here, till 59, the time left was 2k. So this is the latest I have to take my first, so that I can also take the second. If you are kind of getting the logic. Any doubts over here? So the basic logic is put into ranges. I want the biggest in this range. I want the biggest in this range, and this is 1. Okay, I want the biggest in this range, I want the biggest in this range, and I want the biggest in this range. That's what you have to do, nothing else. And
Binary search.
not binary search. And if you want the biggest in a range, you can use a segment tree, or you could use a a multi-set or a map. Yeah, same thing. But multi-set is just way more elegant implementation. Just keep on inserting multi-sets, and when you arrive at a breakpoint, then you just remove the greatest element. Then keep on going ahead. When you arrive, you remove the greatest element, basically. A seg tree is just overkill for this kind of a problem, but okay. So this is where I made these ranges, and here is the segment tree. I am querying the biggest element, and whatever was the biggest element, I am just putting it to -1, so that it doesn't come back, like it doesn't come back handy. Like if this was a 30 and this was the biggest element of the array, so if I were to query here, it would also give a 30, which I don't want. So I just remove 30, which is the update, and we print the answer and AC. Any doubts?
सी वाले में हेलो सी वाले में तो ऐसा नहीं कर सकते अपन कि बेसिकली आई को 0 से लेकर 64 तक लिया, ठीक है, and x plus y plus 2 into binary exponentiation of 2 comma I.
What x plus
वही मतलब x plus y मतलब k को बेसिकली 2 into binary exponentiation of I ऐसा लेने, मतलब 2 raised to I.
2 raised to I. Okay, this has to be
ये
equal.
into 2 होगा क्योंकि
हाँ, तो 2 raised to I plus 1 कर लेते हैं.
into 2 plus 1
should be
equals to
x plus 2 raised to I
x plus 2 raised to I XOR
y plus 2 raised to I.
y plus 2 raised to I.
हाँ,
फ्रंट का टेस्ट केस चला लेकिन ये नहीं चला.
but why will this work? You are checking for all I.
हाँ, पर वो बेसिकली वही है.
But why will this work? मतलब I'll just give a test case. Wait, counter test case ना. This shouldn't work because मतलब okay. Take this test case 1 1 0 0 0 0 1 1 0 1 or 1 here. Okay. Where is this going to work? Not here, not here, not here. Here if we do, okay, let's put this as a 0. Where is this going to work? This won't work. Basically the idea is if you just so the idea is if for the biggest, if two elements, there will be a bigger element and there will be a smaller element. If the bigger element, you increase its MSB by 1, smaller element will have the same MSB or a lesser MSB. And since its MSB has been increased by 1, everything over here is a 0. And whatever I increase here, its MSB is not going to come here. So I can have anything over here, right? So even if I add, it's going to be 1 and added with a 0. So 1, 0, whatever is here, I'm going to mimic it. And even if it is a XOR, I am putting a 1 here and it is still going to be mimicked. So the idea is for the bigger element, you just increase its MSB by 1 place.
Okay, I see.
That makes sense. This case won't work for I's.
फ्रंट पहले काम किया, so I thought this should have solved better.
Any other doubts, people? A, B, C, D.
People are less.
Okay, no worries. Bye bye.